Hello everyone, I am Anik and today we will discuss the paper TraPHic, which is trajectory prediction in dense and heterogeneous traffic using weighted interactions. The paper was published by Rohan Chandra, Uttaran Bhattacharya, Aniket Bera and Dinesh Manocha. The main objective of this paper is to predict near-term trajectories of different road agents in dense traffic videos. The input to the algorithm is the trajectory history of different road agents as observed over a short time span of around 2 to 4 seconds. The output of this is the predicted trajectory over a short time span of 3 to 5 seconds. The approach models two kinds of weighted interactions. First, heterogeneous based, which involves objects of various sizes, aspect ratios, driving behaviors, and dynamic road agents. It also considers constraints such as average velocity, turning radius, spatial distance of neighbors, and local density. With horizon-based, they consider a semi-elliptical region based on a predefined radius in front of each road agent. Overall, the model is a hybrid LSTM-CNN network that learns locally useful relationships between different heterogeneous road agents. The author makes two important observations. The first observation is that in the dense traffic, all the road agents do not react to all the other road agents around them. Rather, they selectively focus attention on key interactions in the semi-elliptical region. The second observation is that the interaction of two road agents differs significantly from the other two road agents. For example, an interaction between pedestrian and car is significantly different between the interaction between a car and a bus. Now, in order to select the architecture of the model, few important considerations are being made. In the context of heterogeneous traffic, the goal is to predict the trajectories. The temporal sequence prediction requires models that can capture temporal dependencies in data. The best example for that is the LSTM. However, the LSTMs cannot learn dependencies or relationships of various heterogeneous road agents because the parameters of each individual LSTMs are independent of one another. For this reason, the ConNets are considered because ConNets have been used in computer vision applications with greater success because they can learn the locally dependent features from images. In order to leverage this benefit, the authors decided to go with a hybrid network of ConNet with the LSTM. Here, through this picture, the author tries to describe the flow of data from input to the output. In the first picture, you can see a red dot which is the ego-centered vehicle for which the trajectory needs to be predicted. A green elliptical region around it is its neighbors for which the considerations are being made. And then there is a cyan semi-elliptical region in front of its horizon. The input embeddings for all these agents are used and these embeddings are passed through LSTMs and eventually used to construct the horizon map, the neighbor map and the ego agent's own tensor map. The horizon and the tensor maps are passed through the separate ConNets and then concatenated together with the ego agent tensor to produce latent representations. The output of the model is evaluated based on two metrics. First one being the average displacement error, which is the root mean square error of all predicted positions and the real positions during the predicted time. The second one being the final displacement error, which is the root mean square error distance between the final predicted position at the end of the predicted trajectory and the corresponding true location. The output is compared between previously developed four models. First one being RNN, which is a sequence to sequence model. The second one being the social LSTM or SLSTM. The third one being social GAN, which is SGAN. And the last one being the convolutional social LSTM, which is CSLSTM. They also have four different versions of the approach. The first one being the TraPHic B, which is the basic version without any weighted interactions. The second one being TraPHic H0, which is without using heterogeneous based weighted interaction. And the third one being TraPHic HE, which is the approach without using horizon based weighted interactions. And the final one being TraPHic, the complete version, which is using both the weighted interactions. Overall, as conclusion, the authors present a novel algorithm for predicting the trajectories of road agents in dense and heterogeneous traffic. The approach is end-to-end, dealing with traffic videos without assuming lane-based driving. They are able to model the interactions between heterogeneous road agents corresponding to cars, buses, pedestrians, two-wheelers, three-wheelers, and even animals. However, there are a few limitations. First one being they do not outperform the prior methods on sparse or homogeneous traffic videos, although the prediction results are comparable to the prior methods. Additionally, the constraints requires the knowledge of the shapes and sizes of different road agents. This was the paper. Thank you.